Hello, everybody. We're going to get started in just a couple minutes. We're going to let everybody pop in from the waiting room. And as soon as everybody's in, we will get started. In the meantime, you're going to see a poll pop up, and we're going to ask that you fill that out just so we know who is joining us today. Okay, everybody, we're going to get started. Thank you all for joining us today, and welcome to our fourth webinar for our LunaRecycle Challenge. My name is Chris Frangione. I'm the acting challenge manager for the LunaRecycle Challenge. Today's webinar is on how to build and succeed as a team. We had some earlier webinars focused on the rules, focused on the digital twin track, focused on NASA's approach to sustainability. But today we're really hoping that you get a good understanding and some inspiration from some folks that have participated in our challenges in the past. They have some great advice and some great lessons learned that hopefully you can take forward as you build your team and as you get ready to participate. First, some quick housekeeping. Um, Today's webinar will be recorded. It will be posted on our LunaRecycle website, which you see down here at the bottom of the screen. We'll also share this link again at the end of the webinar. Although you will not be able to turn on your video or microphones, you will be able to ask questions of our panelists using the Q&A function. So at the bottom of your screen, you should see a Q&A function. By using that Q&A function, we will have a record of all the questions that were asked. And this allows us to answer some after the webinar that we were not able to answer during the webinar. All questions that are relevant to the challenge and your participation in the challenge will be created into written responses that will be posted on that LunaRecycle at ua.edu website. Please only submit questions in English. We will not be able to answer any questions that are not submitted in English. You'll also see a couple of polls pop up. There's one on the screen right now. We ask that you answer these because they really help us understand who you are, what your interests are, where you're coming from, etc. And that just helps us as we think about other ways to support you in participating in our challenge. So today we're going to have four great presenters. These presenters are sharing their opinions only. These are not the opinions of NASA. So what they're sharing does not necessarily represent LunaRecycle as a whole. For any rules or eligibility related information, the only official information is the information found on our LunaRecycle website. Next slide, please. So just to quickly go over the agenda, we're doing the welcome and overview right now, and then we're going to have these four amazing speakers, all of which participated in LunaRecycle, all of which participated in NASA Centennial Challenge in the past. In fact, one of the people here that you will be hearing from today participated in two of them. We'll also do a refresher on the LunaRecycle Challenge, what it is, how does it work, and some key important dates for you to know. And then after the panelists all speak, we will have an open Q&A session. Again, please use the Q&A function to ask those questions. If folks raise their hands, we will not be able to call on anybody raising their hands. So just put everything in that Q&A section. Next slide. So the LunaRecycle Challenge is a $3 million two-track, two-phase competition that focuses on the design and development of recycling solutions that can reduce solid waste and improve the sustainability of longer-term missions for NASA. Our phase one submissions are due March 31st, 2025, in just a couple of months. And again, for more information on rules and eligibility, please visit that LunaRecycle website that you see in the lower right-hand corner. Next slide, please. So I mentioned this is a two-phase, two-track. So the two tracks, you have a choice of participating in one or both of them. The first track is the prototype build track. In this track, solvers will ultimately develop a working prototype of a recycling solution. In the other track, the digital twin track, solvers will ultimately design a digital twin of a complete system for recycling one or more solid waste categories on the lunar surface and processing one or more end product from that. Again, you can find all the details on our LunaRecycle website. You heard me say will ultimately. So phase one is much more of a paper submission, a concept submission. That's what's due on March 31st. That's what has a prize purse of $1 million. Following that, we will have phase two, which will actually be where you have to develop the working prototypes. Next slide. So today's webinar, again, will provide you prospective participants, with practical insights and lessons learned and inspiration on how to form, manage, and succeed as a team. These past participants will share their experiences from their respective challenges and discuss overcoming obstacles, leveraging resources, and planning for long-term success, both from a financial standpoint, from a time management standpoint, and from other standpoints. So I'm going to now hand this over to True. True is the Director of External Affairs for the College of Engineering at the University of Alabama. True and his team at the University of Alabama will be your primary interface as a team. So when you send an email to the email address that we'll show you later on the website, that goes to True and his team. The website is hosted by them. And so they are the people that you want to get to know as a team member. They're the ones that are going to approve your eligibility, etc. The University of Alabama will also be managing the new LinkedIn community that will help you build your team. That's going to be launched right now at this webinar. We'll give you the information on the last slide of this webinar. But that is a place for you if you have a team and you're looking for additional team members, you can go there and see if anybody's looking to join a team. Or if you're an individual and you want to join a team, you have a special set of expertise, you can go there. It's a LinkedIn community. You have to be approved to be let in, but True and his team will let you in. And then you will be able to interact with other people that are interested in participating in this challenge. So I'm going to hand this over to True. I'm going to let him take it from here, and you'll get to hear about a lot of great experiences that some folks had. Thank you so much.
Thank you, Chris. Nice to meet everybody virtually. Again, like you said, my name's True Livaday, and I am at the University of Alabama. So greetings from Tuscaloosa to all of our watchers and viewers from all over the world. My role here is going to be to first introduce today's panelists. Then they're going to each talk a little bit about their journey to how they got to where they are now. And then I'll also be moderating the Q&A. So each of the people who I'm about to introduce are going to give you a brief presentation, and then we'll circle back to me and I'll start the Q&A session. But first and foremost, let's introduce today's panelists. Our first panelist is David Malott. He's the founder and CEO of Space Factory, and he has a hands-on role in research and development. He received a Bachelor of Science in Architecture from MIT in 1996, and he was an undergraduate researcher at the MIT lab. He's a veteran architect with 29 years real-world experience leading design and engineering teams to deliver technologically advanced buildings. including 3 of the 10 tallest skyscrapers in the world. Mr. Malott led the design and construction of Space Factory's first place entry in the NASA Centennial Challenge Mars 3D Printed Habitat Challenge. He served as co-principal investigator of the Relevant Environment Additive Construction Technology, otherwise known as REACT, project in partnership with the NASA Kennedy Space Center, awarded under the 2020 Announcement of Collaboration Opportunity, which became the first team to 3D print regolith polymer composites in DTVAC. Mr. Malott is currently serving as the principal investigator on phase 2 of the Matrix NASA STTR to develop methods of bulk regolith stabilization for surface infrastructure construction, having successfully led the team to meet all technical objectives in phase 1. David is with us today because we thought you'd enjoy insights from a small company as they went through their startup journey. Next, please. Our next presenter is Paul van Shujanta, an assistant professor at Michigan Technological University in the Mechanical and Aerospace Engineering Department. And he's the founder and PI of the Planetary Surface Technology Development Lab, PSTDL, also known as HuskyWorks. Dr. van Shujante's research focuses on robotic systems for in situ resource utilization and construction, and in particular, robotic mechanical systems under lunar and Mars conditions interacting with the lunar and Mars surface. He's actively researching, developing, and testing technologies under lunar and Mars environmental conditions for detecting volatiles in lunar regolith, determining geotechnical properties of lunar regolith, excavating, conveying, and compacting both icy and cemented lunar regolith, excavating cemented lunar regolith, excavating gypsum and extracting water from excavated gypsum and buried glaciers for Mars applications, as well as developing power transfer via superconducting tether into the lunar permanently shaded regions. Dr. van Shujante is principal investigator on multiple NASA and industry-funded ISRU projects with a combined value of over $5.6 million. More information about his work can be found at www.huskyworks.space. Next slide, please. Our next panelist is Arttu Luukkonen. He is the Senior Vice President of Space and Defense at Solar Foods. He holds a PhD in Applied Physics from the University of Jyväskylä, Finland. Prior to joining Solar Foods, Arttu has held several leadership positions in industry and academia, serving as the CEO of a deep tech security sensing company, as well as a research professor at VTT, Technical Research Center of Finland, and the director of Millilab, an ESA external laboratory. At Solar Foods, Arttu led the team that recently won NASA's Deep Space Food Challenge on a spaceborne food production concept that turns onboard waste gases to nutritious and palatable foods. He's also an elected fellow of the Finnish Academy of Technical Sciences. Those last 2 presenters, they're going to talk to us a little bit about navigating the challenge without financial eligibility. Next slide, please. Our final presenter is Nadun Henayaka, founder of Gaia Project Australia, which develops cutting-edge smart farming technologies for terrestrial and space applications. With over 20 years of global experience in engineering and technology, he is committing to building solutions that tackle critical environmental challenges. Nadun is here also talking about navigating the challenge without financial eligibility. I'm going to turn this over to them now so that they can introduce their passion projects and talk a little bit about their journey. And afterwards, we'll return back to me for the Q&A session. Up next, our first presenter, David Malott.
Thank you, True. Hi, I'm David. So our challenge was the 3D printed Mars habitat. Okay, so as its name suggests, we looked into using Mars materials as a 3D printed feedstock developing robotic systems to be able to 3D print very large structures. Next slide, please. And just to give you an idea of the context before the challenge and why I did this. So I've had a long career as an architect of iconic megastructures. I used to work for a corporate firm in New York, and each of these projects you see on the left were about 8-year endeavors. And during the third one, I started hearing on the periphery news of the Mars 3D Print and Habitat Challenge. So like the current LunaRecycle Challenge, it was a multi-phase challenge, and the earlier phases had been going on. And there was one scheme in particular, this ice house, which really caught my fascination and made me start thinking about, well, after having done these iconic towers, what do I really want to do with the rest of my life? The real cathartic moment came when I saw SpaceX land the Falcon 9 on a drone barge, and literally the next month founded Space Factory, with the ambition to contribute to this effort of extraterrestrial habitation. And actually, one of the team members out of that ice house came to join Space Factory, and we started work in earnest on the NASA Centennial Challenge at the end of 2018. Next slide. Okay, like the current LunaRecycle Challenge, the Mars 3D Printed Habitat Challenge was both a virtual design track and a construction track. We started with the design. It was, I'd say it's our, we had a certain comfort level or familiarity as architects in doing a design challenge. Okay, but then we moved into the construction phase. And as I'll explain later, that was far more challenging to us. And we really had to adapt and transform as a team in order to address the challenges of prototyping. Next. Okay, so in the design phase, like I said, we were kind of in our comfort zone, but it was extremely exciting because there's a completely different set of circumstances to design for. Skyscraper architects are kind of trained to design for earth winds and gravity, and in many ways, we're very attuned to the environment and physics as they play out on Earth to shape these buildings. And so on Mars, it was just really understanding the Mars context and letting that drive and inform the design. And so came up with some innovative solutions, such as this sort of egg shape, which was very efficient in terms of containing an Earth atmosphere and the outward pressures that would exert on Mars. And specific innovations like the double shell design, so that the outer shell, which protected from the environments, could expand and contract with the thermal swings and not be restrained by the floors. Okay, and then that would reduce stresses on the design. Next slide. Okay, but when it came to construction, and here we really faced a fork in the road as a company. We could have just ended with the design phase. We tied for first place. We could have just sort of sat back and patted ourselves on the back. But I just sort of felt it would be more real and more challenging, more fun to really go and prove out or prototype this first build. But we'd never done a big print before. We tried to find a large format 3D printing partner. Okay, and really they're very few and far between at the time. There's more now, but at the time we reached out to a few people and couldn't find a partner. So I made the decision to risk it. Even as a very young company, I said, let's go for this. Let's put in our resources. Let's see where it goes, because ultimately this is really where the problem lies. It's not just the design, but it's in the development of the technology. What you're looking at is our very, very first 3D print. The material is a PLA basalt fiber. So the rules of the competition stated that we had to use Mars relevant materials. So we had to work to the rules, okay, which is one of my bits of advice for teams, is really understand the rules. Okay, next slide, please. Okay, and so we had to acquire new skills, okay, and we had to develop partnerships and collaborations outside the company. I think the big difference between design and prototyping is that prototyping is engineering intensive, it's resource intensive. In other words, it's going to cost you more money than just doing a design, or in this case, the digital twin. We hired our first real engineer to lead the prototyping effort, and then transitioned like our more technically inclined architects to becoming like these robotic 3D printing operators. One of the most, let's say, critical partnerships that we developed was with Autodesk Technology Centers. Okay, and they weren't exclusive to us. In that little image, I don't know if you can see, there's a yellow robot. That's Apis Core, who is also competing in the challenge. So we had these two teams in the same center working on the same problem. We were using this PLA basalt fiber approach. Apis Core was doing it in concrete. Okay, Autodesk Tech Center, by the way, was a free resource. You just apply, present the problem, and you just work there in a fishbowl environment. That would lead to later collaboration with Virginia Tech, who would supply us with the equipment that we used in the actual challenge. Next slide. Okay, and just getting to the challenge, the final challenge, was probably one of the hardest things we had to do. So, and I think most of these challenges kind of end in a final sort of head-to-head showdown between all the finalists. So it involved things like, dress rehearsals, loading our robotic printer, mounting it to a forklift so we can move it around, loading up the whole thing, transferring it from Boston to Illinois, where the challenge was actually being held. As we were doing this, we started publishing our story on Instagram, and actually gained quite a momentum heading into that final challenge. Next. Okay, and this was what the challenge looked like. So we were in this vast arena. We were given only 1 day to set up our equipment, okay, and 3 days to print. And I think it's just the logistics of getting to the challenge probably prevented most teams from being able to get that far. So at the end, it was really just a head-to-head with us and a team from Penn State, a concrete solution versus our polymer solution. And, this is when Murphy's Law kicks in. So after about a year of working on this project and, hauling everything on trucks and setting up, we realized we forgot the keys to the forklift that raises up our robotic 3D printer. Luckily, we were in this Caterpillar facility, and they had the master key because the forklift happened to be a Caterpillar, so that kind of saved the day. So lots of like real world obstacles, Murphy's Law sort of scenarios will kick in as you move through the challenge. Next slide. Okay, but by far, I think this was the most fun and rewarding and exciting part of the whole journey. And, I assembled this team, provided them guidance. At the end of the day, as we started printing, I said, look, in my mind, we've already won because we're here. And just do your best, no pressures. But I think at this point, the team was really sort of inspired by what they were doing. They wanted to win, and they just executed remarkably well, from 3D printing the shell to autonomously, placing windows and skylights. I think one of the most thrilling moments was surviving this Caterpillar excavator crush test, where this big machine was actually unable to crush what we just 3D printed. So it's really like a once in a lifetime thrill. And I can't emphasize it enough. Next. Okay, but like immediately after the sort of euphoric bubble came the what next. And, you know, maybe this is a discussion we can have with teams down the line, but, you know, if in hindsight, if we had done a little bit more thinking about what we do after the challenge, it would have helped us as a company. And because going through the challenge will transform your company, it's going to transform you as an individual. And navigating NASA after the challenge is not a given. And it is a very large organization, very complicated, and thinking about how to take your products into space and finding applications for them on Earth is maybe something you want to start be thinking about, you know, even right now. Next. So this is where we are today. You know, so we started as an architecture company. We are now, you know, engineering led, and we are still pursuing the space goal. The image on the upper right is, you know, 3D printing in a dusty thermal vacuum. Okay, so this simulates lunar conditions. So we're printing with a lunar simulant and PLA at temperatures negative 170 degrees Celsius in vacuum. Okay, so it's incrementally advancing the technology. So, you know, what has started as just a design vision is becoming more real. And I would say, you know, in terms of NASA's technology scale, we're at 4.5, which is exactly halfway between 0 and the moon. So encouraged by the results there. But we still have to pay the bills. And this is where the dual use applications become very important. Thinking how you can pivot out these technologies that are space driven and finding Earth applications for your inventions. So I know it's a lot to talk about, but next slide. You know, so, you know, in terms of how you go about this challenge, if I were to, you know, offer advice, you're probably at the top line, which is, you know, gain as much knowledge as you can right now. You know, talk to the SMEs, you know, build up your knowledge base, formulate your ideas and build your team. Okay, and I think you're probably, you know, at that moment right now. Find your mission and rally your team around it because things go wrong and the mission is the glue that holds it all together. Test and iterate and definitely meet milestones. Read the rules. Okay, NASA is very precise. If you miss, you know, one little checkbox, you could be disqualified. And don't be late. Okay, I've submitted a proposal 30 seconds late to NASA and it wasn't accepted. So they're very, very serious about deadlines and milestones. As you head around the corner to the final challenge, understand, okay, it's going to be, you know, there's going to be a lot of resource constraints you have to overcome, logistical burdens you have to manage. Just have that in mind. Okay, ultimately, I think we won because we were the best prepared and we executed. At the end of the day, it is a contest. It's a challenge that occurs over the course of a couple of days. So how you execute over those few days is extremely important. And finally, and part of the reason I'm doing this is just to share your story. So you saw us posting on Instagram. You know, I think the challenge, it's interesting because NASA is essentially crowdsourcing a problem to the world. And these are usually inspirational problems that don't just address space, but solve challenges on Earth. So, you know, as you're moving about this, think about how you're sharing your story. It helps to motivate your team. It will pull in collaborators and contributors to help in your effort. And if you go out and seek fundraising, you know, it also helps to have that story. Okay, and after all that, I will say in hindsight again, is just the beginning. So winning a Centennial Challenge is just the beginning of a long effort to actually realize these and to see your ideas actually materialize in space. Okay, all right. So with that, I will pass it on to the next panelist, who's actually one of Space Factory's collaborators on the academic side, Dr. Paul Van Sissant.
All right, great. Thank you, David. Very inspiring journey you have there. All right, so my name is Paul Van Sissant. I'm assistant professor, mechanical and aerospace engineering. I've been here for about 12 years. Next slide, please. And I have been lucky to participate in quite a few competitions, going actually all the way back to 2008, one of the first NASA Regolith excavation challenges. And then again, 2009, we participated, and that competition then morphed into Lunabotics competition, which is an exclusive student competition, in which I participated quite a few times. And also, I volunteered as a judge one year where I did not have a team participating. That was 2018. I actually was one of the subject matter experts on David's 3D printing habitat team that won. So that was excited to have my tiny little contribution there to get them to win that competition. But as a university, we have a very different viewpoint in the sense that I guess my product, so to speak, is my students, and so the job here is to provide them with experience, but also, of course, to develop the technology and contribute to NASA, in this case, getting to the moon. And we do that by collaborating with a lot of different partners, both on the industrial and academic side, as well as with NASA. But the nice thing is, of course, that when we talk about team building, I have a lot of students that work here at the university and that I can sort of choose from, if you will. And so we started first in 2020 with the Big Ideas student competition, and we won that competition. That's a student competition, which then gave us some ideas and experience that then led to us contributing to the NASA What's on the Moon Challenge, which was announced in 2020, and then we won phase one. Then we decided to continue, do phase two, and phase two had multiple levels, kind of like this one. And so in this case, we had level one, level two, and level three, where level three was the final round. And as you can see, from the journey from 2020 to, in this case, the finals being in June 2024, that's like almost a 4-year journey. And there's many different steps, many different deliverables along the way. And then, we also decided to participate in the Break the Ice Lunar Challenge. Again, we have a lot of students, and so, I managed to have 2 teams in this case. We also participated starting in 2020 there with the phase one. We were runner-up there. We did phase one, phase two, level 1, 2, and 3. We were also one of the selected finalists there for this past year. So last year, we actually had 2 finals for 2 different Centennial Challenges. And you can see some pictures here of the team meetings. We had a student team with the robots for the Break the Ice Challenge, and then the robot on some of the obstacles that we had to overcome. Now, one of the challenges David already mentioned was the logistics of that. And so, we are very far north here in the United States. And so driving and transporting all of that equipment, the robot, the tools, everything you could possibly need, from here to, in this case, Alabama, where the finals round was, it was quite challenging. I think we brought 16 students with me. So it's a pretty big team. Next slide, please. So it has given us quite a lot of experience. But one of the things that we do here is we teach them how to solve problems. And so, this is just an engineering problem like many others. And so you start off with requirements, you come up with the projects, and you go through that whole process. And as you can see from this list, we have been quite successful in winning the different phases and awards. Next slide, please. Then, fortunately, because this is also my area of research, we have quite a lot of facilities and test capabilities around. And so the students, while they develop this technology, could then easily use these kinds of facilities. But on the other hand, we also partner with other organizations that can also then use for a cost fee, these facilities that we have. And we're not a for-profit entity, so basically it's just cost. But it is important to realize that these things are out there, maybe closer to you, but we have some of these facilities around as well. And so if you got to test your lunar stuff, we have a dusty thermal vacuum chamber. And so we're partnered, for example, with David's company, Space Factory, on some of the projects he was mentioning so that we can test that technology under lunar conditions. Next slide, please. And so the conditions are really, really important to understand. They're very different on Earth, and they have different implications on your design and things like that. And so, we do a lot of prototyping, we do a lot of testing, and then eventually when you're kind of ready to test, you do the expensive tests, in this case, the dusty thermal vacuum chamber testing, or large scale vehicle testing with lots of lunar simulant type things, so that you can test your full system in an environment as close as you can to what it's going to see when it's going to work out on the lunar surface. Or Mars or wherever you're going to go. Next slide, please. So as a last slide here, I have a couple of points that I wanted to bring up to, how do you have a team? How do you deal with a team? And so it's really important that you have strong leadership. And with strong, I don't mean somebody that tells everybody else what to do. But in this case, leadership as in guidance, having a good plan, good documentation, somebody that really reads the instructions. That's something David already mentioned. There are very small things that can cause you to be disqualified if you miss them. So you really need to have leadership that really delves into that and spells out kind of for the team what is important. Trust your team. Trust is earned as well, and so people need to perform, and that's a really important factor here. Go for the mission. You make sure that people really want to win and want to participate. Now, it's in turn important you have dependable team members because of that, because there are strong deadlines. You cannot be late, and so things need to be done at a given amount of time. And that also means that if somebody is falling behind, but they don't let you know about that, that can be problematic. So it's crucial that it's okay to ask for help, for example. But that also means that the managers need to understand where you are in the schedule and where you're supposed to be, so you can manage whether or not you're falling behind and see if certain pieces or sections need more resources. All right, and that brings you to the third point, a good project management. And so understanding what you need to do in the time it's given and figuring out, how many resources, and resources can be people, money, space, facilities, even software, all these kinds of things, you have to make sure you have them in place to finish what you need to do. And of course, you run always into challenges, right? And so in this case, we're a university team, and so students, this is not their job, right? Their job is to go to class and learn things and pass their classes. And so sometimes exams get in the way of other deliverables, and so it's important to sort of manage these kinds of conflicts in a way where you have to make sure you have things done before the exams so that they can not fail them, of course. One thing we have learned as well is that if you have one single individual around which everything turns, the technology, and that person gets sick, or in our case as a student, maybe they have an internship, right? Then your project kind of stalls, and it is really important that you're not dependent on this one person completely. Somebody else needs to know enough to keep moving forward, right? So you don't stall your project. There's lots of other things we can talk about, but my time is up here, and so I'll be happy to answer any questions later down the line. Next slide, and I'll hand it off to R2 next. Thank you.
Yes, good evening or good morning. We are based in Finland, so for us it's evening. It's tremendously interesting to be in this seminar and some wonderful folks already. So we were participating in the Deep Space Food Challenge with this concept of making food out of thin air. And I have a few slides here just to put you into sort of the context of where we come from and how we built a team that was selected as the international winner of the challenge. Next slide, please. So what we do is basically making food out of thin air in a way that is completely disconnected from agriculture. And as you can well understand, sort of traditional agriculture in either lunar environments, Martian environments, or even orbital environments is pretty much impossible. Next slide, please. And how we do this is basically that we use electricity, turn electricity into protein. And we do it by using the electricity for, first of all, capturing CO2 in space conditions, basically from the cabin air, from the respirated carbon dioxide from the crew. And then we use the waste hydrogen that is the byproduct of oxygen generation by the ECLS, the Environmental Control and Life Support System, because this bacteria that we ferment uses hydrogen as the energy source and carbon dioxide gas as the carbon source. Then we also feed it with a nutrient media, which is basically water, and it has some minerals. There could be some connection between the LunaRecycle challenge here, because we are interested in recovering these phosphates and sulfates from basically human feces, which we don't currently do. And at the end, if you go to the next slide, the end product is a protein powder, sort of 70-75% of protein, with some dietary fibers, some fats and minerals, with a very mild taste, and something that we can use as a food ingredient to replace basically eggs or dairy as the obvious ones. And there are a number of other things that we do with it. Next slide, please. So this concept that we proposed for NASA did indeed end up with this recognition, and I'm now trying to justify why we participated here in this challenge as an international participant. We are based in Europe. This was a NASA and CSA, Canadian Space Agency, run challenge, which meant that we were not eligible for any prize money. So why did we do it? Next slide, please. So from the background, this is the first Centennial Challenge that we've ever participated in. We understand the motivation of the agencies because deep space exploration, human exploration of the solar system is unlikely going to be possible without producing food in situ. It's partly due to outmass, spoilage, and degradation. And there are actually some interesting sort of leveraging benefits that you get if you think about these biological systems and how you couple them with the existing physiochemical systems, that we can close some of these gas loops that are currently partly open. And in principle, we have demonstrated that these sort of fully enclosed ecosystems are possible, which means that basically from a human fuel standpoint, you have an infinite range. And the benefit to Earth is also of something of great importance. For instance, Solar Foods is a company that our main business is on earthbound alternative proteins. And that's where most of the revenue is going to come in the next 10 years. But if we go into this sort of space environment, that is the ultimate test of a circular economy, which we should implement on our best spaceship, which is, Spaceship Earth. Try to close our, the systems, ecosystems that we people live in order to reduce the burden to the rest of the planet. So these are the kind of the motivations from, let's say, agency side that we understood. Next slide, please. And our motivation, so I said that there was no prize money in it for us, but we have no space legacy as a company. So one reason was to establish the contacts with the relevant players and people in the field, learning about new things about manned space flight and the environmental control life support systems and food in space. And we also appreciate the fact that the requirements for a spaceborne food production system with respect to automation, stability, maintainability, and overall kind of reliability are orders of magnitude higher. So if we can implement those innovations into our Earth factories, we believe that we can make food cheaper. And there's been an enormous amount of visibility and recognition that we received through the stages 1 to 3 wins that we did. And we've been leveraging everything out of them. So using social media and our webpage to tell this story. And because we're making food, and it's a novel food, something like a new harvest to the humankind, the general public sort of in general thinks that, if astronauts are being fed this stuff, it can't be very bad from a nutritional standpoint. So there is kind of a brand value that comes with that. What was the main thing that we walked away from this? So the judging panels on these challenges are very, very well educated. They are superb experts in their fields, coming from NASA, from academia and industry. And they're picking us as the winner basically validates the concept of what we are proposing. So that was let's say the biggest walk away from the prize. Next slide. And by the way, in the picture here, I'm talking to Tim Kopra, who's a veteran astronaut and the CEO of Starlab, one of the private space station companies that will be launching stations in the next couple of years. So incredibly useful contacts that were achieved during this the challenge. Next slide, please. So actually, let's just go to the next slide in the interest of time. I just want to briefly say what the kind of the winning concept here was. So our biggest value proposition for space habitats with respect to like upmass and sending consumables hasn't anything to do with food. It's to do with the water economy of habitats. And because of our microbes using hydrogen as the fuel and CO2 as the carbon source, we can close these partially open hydrogen and oxygen loops, which means that we can save 200 liters of water per crew member per year. And that's a lot of outmass that we can save, in addition of producing nutritious protein for the crew. Next slide, please. So it was a long journey. I mean, there were plus 300 teams that participated from 32 countries. And it was exciting to be in all of the phases. We made some great connections. Nadoon, who's the last speaker, has become a dear friend, and we have some great discussions. So you're also making a lot of connections with your co-challenge participants, and please use those and generate value from those. Next slide, please. So cost offsetting is a big problem. I mean, I've seen in the chat a lot of questions about this. So we are a European company based in Finland. No money, prize money for us. Also, the company, we are a scale-up. We're investing 40 million into our first factory. All of the money that company has goes into the earthbound factories. So I had this somewhat of a challenge of justifying us participating to the challenge to my boss, our CEO, and also to the board. And I think one of the, let's say, transformative things here was that we managed to secure not a lot of money, but some money from the European Space Agency. So we had this open space innovation platform project, something like 200,000 euros, which is a really, and if there are any European contestants or thinking of participating, please look into it, because it's an easy, very lightweight application process, and you get the contract quite quickly. And without that OSIP funding, I don't think we would have made it to phase 3. So that helped us. I mean, it certainly didn't cover all of the costs, but it helped to offset the costs that we generated during this challenge. The other thing that we used a lot was the fact that we did have a fair bit of infrastructure and hardware in existence that we could then basically adapt in building a demonstrator for the challenge. The requirements for international participants, at least in the Deep Space Food Challenge, were slightly different. So we were not required to send a system out into in the US, but we basically remotely demonstrated, which was basically the only viable way of doing that because of customs and shipping and everything. But look into this, and if you come from another country, please do take a look at your national space agencies if they have some funding platforms that could support you with this. And then you need to, of course, disclose that. Would you mind if we use the results here that we could participate in the challenge here? And usually the agencies are okay as long as you're kind of careful with the IP, that you're not handing out IP to NASA for free, which they're not expecting you to do. Okay, next slide, please. So what next? We're basically expected to fly on the ISS in the next 2 years, a small-scale experiment. We're looking basically into establishing cooperation with the commercial LEO destinations companies, because we can save them a lot of money. and then building a ground-based tech demonstrator. And I think this was my last slide, so I'll shut up with that then. Thank you for your attention. Oh, and I'll hand over to Noon, sorry, at this stage.
Thanks, Artur.
Nadoon?
Good to see you again. And yes, as I mentioned, it's always good to meet some great people. So I'm Nadoon. I'm from the land down under, or we call it the Australia. And great to talk to you guys about what we have done and our experience on the Deep Space Food Challenge. So today I'll give you a rundown on our last 3 years of working with NASA and the feedback and what we got from it. I think the key thing, just like Artur mentioned, for us, yes, it wasn't about the money. I mean, yes, money is important, but for us, it was key reason was the validation, which was something we really needed. So at the time, back in 2020, when this all started, it was just an idea. And then we just did our initial research, done our initial patenting, because again, when you publicly disclose any proprietary information, you have to be wary about what's the future outcomes going to be. I'll go on this later on down the presentation, but that's what I want to highlight. So it's mostly about, if you think you have a great product, try to jump in this program, even though the challenge doesn't give you any money. If you're an international company, that's one of the key hurdles that you had to face, and find a way to go around it. Because for us, I mean, in the last 4 years, we went from idea. Now we just completed our seed round. We have commercial manufacturing in Australia and also overseas. And then we actually building our first customers project this year in Australia. And also we have several in our pipeline for overseas countries. So it's definitely a great ending. And I think the Deep Space Food Challenge definitely helped us to reach where we are currently. Next slide, please. So for us, as I said, it all started back in 2020 during COVID days. I think a timeline we all trying to forget. But one of the key problems we had earlier days was to get the validations for our technology. So what we build is a new cultivation system for indoor farms. So that's including anything from a vertical farm to a greenhouse. And key is to have efficient cultivation system. So what we done was we built a growing bed that can grow with the plant. So basically meaning at any given time of the growth stage of an indoor farm, the system always have highest amount of crops in it. Because the challenge for Deep Space Food Challenge was for us to build a system that uses most lowest amount of research to the highest amount of output. To achieve that, you had to use the lowest amount of space, water, energy, and everything combined. So for us, we knew it was a solution, but we couldn't get any proper validation, even though our testing come up positive. So going through NASA and then having these amazing judges judging our technology. And for us, we won the International Innovation Award in 2021, and we won phase 2 and phase 3, we were the runner-up. To have that validation really put a solid belief on our technology, that we then got the investors, we got a lot of universities, private agencies backing up. So again, I just want to highlight this. It is a great opportunity if you think you have a great and a unique product. Next slide, please. So how to do all of this in a smaller budget, that's the key for most of the international teams. I wouldn't know much about the US because you do get the supports. I mean, still the first stage or the phase 1, you still have to do everything on your own. So for us, I mean, when we started, I didn't have any experience on CAD 3D printing. I mean, my background is hardware engineering, so it's quite a new challenge. So there's a lot of things I have self-learned and then going through it. But the key thing for a longer duration, think about the longer life of this project and what team do you need, because that's very critical, you know, because if you're building something, I'm giving from my experience, we need the engineering, agronomy, a lot of the other segments need to come together to build this single solution. And at the same time, you have to find the people that were willing to initially probably work for you for free, and then, you know, devote their time and energy just to get something done as an idea. And eventually, you know, if you're lucky and then if you have a great product, then you will succeed and then, you know, come to a position that like we in currently, which we think is very fortunate. Next slide, please. So again, on resource leverage, like I said, highlighted earlier, it's if you're a single founder and if you just have an idea and want to apply for this, and if you think it's a great idea, please do so. I mean, for me, it was one of the best decisions we have made. I mean, yes, it cost us a lot. We didn't have much support even on this Australian Space Agency, or anyone didn't really support us even when we had not phase 1, not phase 2, not even phase 3. So it's all our friends put the money in, and then we had several grants that came in towards the end, which was really helpful. But one of the biggest benefits we had was universities. So again, if you're a small startup or a small company, try to work with universities because they're the best avenue for you to get the help that you need, the team that you need to develop a very complex piece of technology. It depends if it's a hardware problem, because for us, it was a very complex piece of hardware that we had to build. And yeah, once you have the team and then the resources, it's quite easy to move forward with it. Next slide, please. So I think like Atu highlighted, it's for international teams, money is a key issue because you had to understand building initial phase is a design, but then if you progress through phase 2 and hopefully to phase 3, it's going to significantly cost a ton of money. So I have to understand where that resources come in. So I think even David and also Atu mentioned earlier, so the key thing is have a strategic vision. This is the most important thing. It's like, don't just build stuff for space, have a terrestrial use. I think NASA highlighted this in the deep space project from day one. It's like, how can this solution that we're building applies for Earth? So for us, I think one of the example is we even use the same testing that we use the same motors, the lighting or the irrigation controller systems, disconnecting from one, testing on one unit, and then moving it to another because they cost several $1,000s. So it's a matter of, can you build something that is suitable for space or for the application that you're doing for the challenge, but at the same time that you know it has a solution for terrestrial use. Because if you have that, no matter if you go through the challenge or win it or not, you have already built a secondary product that you can enter into the market with. Because the idea is, space is a very small industry, and as mentioned earlier, NASA is a very complex beast. You know, it's a lot of moving parts. It has a lot of things to go through. So if you're going to go just on phase alone, it's going to be taking a long time, but having built a solution that can work on the terrestrial platforms as well will help a lot for you to move forward with funding and capital raising and getting the right teams, because it has a direct application for Earth use. Next slide, please. So for us, moving for the last 4 years, as I mentioned, we completed our seed round now. So after 4 years, we had a pre-seed where we just get money from family and friends, and also utilizing a lot of the grants that we're getting in Australia. So most of the money we space between our Earth testing projects and also for NASA. And then through that, for this year, our plants are doing a huge amount of automation manufacturing in Australia, and also our commercial manufacturing of our plastic components in Australia and India. And 2 projects currently in the pipeline for the next 12 months, based in Melbourne, and another one in central India. And for the global expansion, we're looking at partnerships next year, moving into EU side of the world, and also working further towards into complete supply chain development. And one of the other things, outcomes from Deep Space Food Challenges, we're actually working with another space program called Plant for Space. It's a 7-year program that has over 35 universities combined. We're going to be one of the hardware providers to test their things they're planning on to do with Luna and Mars missions. And we also in chat with several other people that we met during the program with our challenge over the last 3 years about other space programs that doing smart farming or crop cultivation testing for both Earth ISS, Luna, and Mars programs. So the idea is, if you do get involved and if you get to meet a lot of people, mainly directly inside NASA, and that who are really helpful, very knowledgeable, that can give you definitely much more knowledge on what you're developing, and also maybe potential to open up pipelines to help you further develop and build new partnerships. And yeah, that's it from me. Thank you very much. And I will pass it back to True.
Thank you all. That was tremendously interesting. I want to tell all of our viewers that if you have any Q&As, please make sure to submit them via the Q&A menu at the bottom of your Zoom screen. I have noticed that we've been getting a lot of questions about sort of technical details and things like that, and that's kind of really not the type of questions we're looking for. We're looking more about questions about the team process. You know, we've got representatives who are international. We've got representatives from universities, you know, so if your team involves a higher education institution, you may have some more specific questions about that. And of course, we also have, you know, startups who had to use different angel investors or anything. A reminder that the website for the LunaRecycle Challenge is lunarecyclechallenge.ua.edu. So if your question is highly technical or about eligibility, I recommend that you go to that website and you read the rules document. You may have heard this earlier in this webinar and even from some of the presentation. The rules are very, very important. Also, registration will be opening soon. And if you got an invite to this webinar, your email address is on the list. So when registration is open, you will receive a verification, or I should say, an announcement that registration is now open. The registration is a technical process and it has several things that you need to submit. The Q&A page is not a page to submit your ideas or ask anything about that. This is mostly about the team process. So just keep those questions rolling in, specific to teamwork, or you know, you might be interested in bottlenecks that these teams ran into. What were the biggest difficulties they faced? What were some things that they got out of it? Basically expanding on the presentations that you just saw right now. On that note, I'd like to ask the first question, and I think the way we can do it is if everyone who just presented over the past few minutes, if you just listen and you can just chime in, and if you need to pass it along to each other, please do. Several of you spoke about the cost of competing. I'm detecting that there's a lot of interest in this topic. You know, so we talked about a few things, but I was wondering if any of you would talk maybe a little bit more about the difficulties or about maybe more specific strategies that you use to offset the cost of competing in a Centennial Challenge. Thank you.
Yeah, sure, True. I can start on that. I would first say to participants, don't do this for the money. Okay? Because even if you win, if you go all the way through and win, you might just even break even. That's at the end of the day, Space Factory added up the numbers and we won top prize, $500,000. That was basically our own investment into the challenge. Okay. And, you know, for us, you know, we're a company, we were paying salaries. So I would say, you know, 80, 90% of that was salary. And, you know, one thing that we did do is we leveraged, you know, free resources at Autodesk and later with Virginia Tech to offset equipment costs. You know, if we had to pay for the equipment ourselves, that would have made it impossible for us. So I think it's much less of an issue when you're working on the digital twin. You can use open source software. It's a matter of sweat equity. That's very manageable. When it comes to prototyping, especially in the later phase, you just need to be prepared and to go out and seek these resources which may be available. I'm very cognizant of this problem, especially for, say, you know, disadvantaged teams, overseas teams. I can't make any guarantees, but one of the things that I am trying to do in my capacity helping out with this challenge is to raise a prize purse, okay, to help fund teams that don't have access to resources. The challenge, you know, it's crowdsourcing ideas from the world. And I think for NASA to get the best ideas from the world, we need to do our best to eliminate that friction of resources. So again, no promises, but it is something, at least personally, I am very focused on trying to be able to provide to teams who can progress on to phase 2.
R2?
Yeah, I wholeheartedly agree with David that the money is not the reason to participate in the challenge. It's very unlikely that you end up on the plus side. We certainly didn't. So the value of participating in the challenge and being successful in them is in the recognition that you receive from a very prestigious government agency in the United States, the most prestigious space agency in the world. Which, if you are a university team, students, and you're thinking about a startup, you can bootstrap. You can do things, hack away with very little in the beginning. If you get through the phases, you will have a very, very potentially fundable startup with VCs potentially lining up to fund you. So this is a recognition prize primarily. The prize money will, reduce the hurt a little bit at the end potentially. But yeah, the money is not the way to go. For those international contestants over there in India or Europe or any other part of the world, one of my sort of personal laments about the NASA Deep Space Food Challenge was that it wasn't the NASA ESA Deep Space Food Challenge, because the European Space Agency shares the same challenges. But because of maybe the political machinery and whatnot, ESA, I think there was some discussion at some stage of them participating. But I would urge any international participant, especially if you're a university team or already incorporated company, because you can't get space agency funding unless you're kind of a legal entity. Individuals usually don't get funded by space agencies. So talk to those people. Try to find kind of a seed funding from your national, whether it's a space agency or national kind of a technology research agency, and say that you're looking at participating in this, and that this could be a great boon for you as a entity. So pick up the phone and call these people and say that you're looking into participating. How is there some funding that we could get to support us from our national side, because no prize money is coming our way.
Any other comments on that subject? Paul?
Yeah, so my view, of course, is a little different in the sense that I'm from a university setting. And so,
Excellent.
I don't want to say students are cheap, because I actually do pay my students, but relative to a full-time engineer at a company, they're relatively cheap. And so, especially in the first phase, when you don't have any prize money yet, we always run projects, we always run project teams, we give the students experience designing things. And so these are great challenges for the students to start figuring out, hey, how do you design something? And so the initial phases are pretty nice to work at a university. Now, of course, the further you go, right, so the more hardware you might need, the more test facilities. Again, the university has infrastructure available, which we can use for this kind of competition, assuming you participate as the university. And so we can use the facilities, but the hardware is still expensive. And so even though we are cheaper, the money still doesn't usually cover all the costs, like the previous folks already said. And so it's not really a motivation to do it for the money, although it's nice because it does allow you to do things. But I think in the end, right, so for the students, it's about experience. You could show you've got a really good project you worked on. Like I said, for NASA, for a very prestigious, very well-known entity. And so it is pretty amazing if you get even runner-up prize or you win. It's really good recognition of the quality of work that you've done with the team. And so if you are a student or even somebody looking for a job later, say, look, I've done this, I've participated in it. That's where a large part of that value comes from. And of course, the networking, like somebody else mentioned as well. And so even though the monetary value doesn't cover the whole cost, there's a lot of intangible benefits of participating in there.
Thank you.
Yeah, true. I just want to quickly add to that what Arthur and Paul said, and also David. It's the validation. So if for us, it was a very unique opportunity because I was a single founder, idea stage, just got the initial testing done. If you ever have an idea, if you think it's great, if it's a great solution, either hardware or software based, you have to get it to the market. You have to have an MVP to validate it, to people to believe. So ideally, you might get some customers on your local region, but if you spend a bit of money, time and effort, you get the validation from NASA. I mean, that's something money can't buy. You can't go and ask NASA to test something. That will never happen. But the opportunity, like through these challenges, you get to get your product, design it, validate it from the best engineers and the best judges. Because if you get that, like for us, I mean, that opened a ton of doors. So that's one of the things is, yes, money's going to be hard. Bootstrap it if you're international, but the outcome will be great if you have a good solution. Thanks.
Thank you. And Nadine, I'm going to kind of hang the hat on you for the next question, because you said something at the very beginning of your answer that I thought was really interesting, and it pertains to another one of our questions in the Q&A. Okay, so you said you started off as an individual in this
Correct.
event.
Correct.
Okay, so I'm going to paraphrase, but did you feel like how long did you stay as one person? Like, did you feel like you were at a disadvantage? You know, and then
100%.
I'm going to pull in a second question. So somebody asked, you know, as you pulled your team together, eventually you're ensuring that your team is multidisciplinary, right? So do you find good people and train them for the skills they need, or do you find the members and then who have the good skills and then form them into a team? You know, like, what was
Yes,
it like being an individual? It sounds very, you know, difficult to kind of get everything rolling.
it was a hard journey. I mean, 2020, I resigned from my work. I decided to go on my own full time, and engineering was even CAD. I had to self-learn night school, and I did night school after that on agronomy just to understand the fundamentals. So I spent a lot of time and effort, but what I said kind of covers back this. It's because for me, I knew no one believes the technology I built as an idea. But to get the validation, this is the best and the cost-effective part to get the best validation from the best people. So for me, it was not a question. I'm like, yeah, I had to probably spend 15, 16 hours a day for a year straight. That's kind of what I did. But in the end, it was great. So after that, after we won the first phase, then we had some traction, which was universities. When I went to speak to them, they're like, oh, wow, you know, you kind of got this idea through, and then they accepted it in stage one. So it kind of built it from there. Then after that, I mean, my current engineering team is we contract through university because we love the team. It was the initial team we met, and after 3 years, they're still our engineers. I mean, we have multiple engineering companies now, third party, but the core team is still the initial team that we met back in 2021. So yeah, it's building from there. Then on top of agronomy, no one has that skill set. So we got external agronomists to test our technology and also building them on the team. So you have to find out what you're good at, what you can self-learn, and then pick the other ones slowly, because in the end, for the first few years, it's free labor. So a lot of people don't want to work for free until there's something on the other end. So I mean, space is a good space to work in because everyone loves space. So that's the additional benefit you might get.
I understand. Does anyone else have any insight that they'd like to share on that one? I know that this might be a unique situation, but we have noticed a lot of individuals who are interested. Finally, sort of the final dovetailing into this final question, forming teams. So I'm curious more about the mechanics, if you will, if you have any specific examples of how this has come up already in this Q&A and also in the presentations, but do you have more specifics about navigating the matchmaking process? And Nadine, I know you were the last person to answer, but you don't need to start off on this one if you want to think about it for a minute. But do any of you have any comments about navigating matchmaking and things of that nature? R2, do you have your hand up there?
Yeah, I mean, we were a single team, so we didn't partner with other um, organizations or individuals during our challenge. But I would say that in most organizations, especially for international, because there's no money, there is some internal sales work that you have to perform on how do you ensure. Let me just say that, you know, in our case, we're no longer a startup, but let's say a scale up, where everybody's like super busy, and you know the bandwidth of all experts in the organization is full. So how do you convince people to dedicate their precious little time into something that will not generate any revenue? Because for a company, that's kind of a big deal that you need to do. But for me as a team leader, the main thing was that despite us being a earthly biotechnology company, many of our talented employees were like super excited about the space thing, and they kind of made room for this activity. So we had this sort of I didn't even actually have like a full-time team in terms that, you know, I had like 5 people working for the challenge. I just pulled out different people at different times to contribute to the various aspects of the system design that it eventually won. And I think NASA is I don't think it's necessary from the challenge standpoint that you have to have multiple partners. It's really the idea and the concept, what you're proposing, that maximizes the value. So you need the team that maximizes the value, but, you know, building a large team, unless it makes, you know, perfect sense, is not necessary. So you can have a single entity that is proposing for a challenge, you know, proposal. So it's not like these European projects where you have like 12 partners just because you need to have every member state included. So you don't need to do that. If you have the full package in your organization or your team or your startup, you know, don't try to. I mean, the different stages during the challenge may give you an opportunity to partner, because then you learn who are the other contestants, and you realize that, oh wow, there's a perfect synergy here, so let's work together. So, but you know, in phase 1, unless you have a crystal clear idea of that you're lacking something for this particular thing that you're proposing, you know, you don't need to spread your team. Just go along.
Yeah, I think that's the real benefit of the way that NASA structured this as a multi-phase challenge, you know, and I hope in us speaking, we're not scaring people from joining in, because the barrier for entry for phase 1 is very low, right? You know, even the hardware track, the prototype track, you're not required to deliver a physical prototype. It's just designing it and preparing a budget, showing that you have an awareness of how much it's going to cost, and developing a plan for how you would address those resources in phase 2. So you can enter it, okay, and, you know, use as much of your sweat equity as possible. And you scale up your team as you go. If you achieve success in a phase 1, you realize where you know, maybe you're very good at coming up with the idea and drawing it up in CAD, but you need engineers on your team later. You know, that can come later. So I think you realize where the shortfalls on your team is, and whether that's, you can pull someone into your team directly, or, you know, seek outside help, you know, universities, Autodesk Tech Center, external resources. So scale up as you go, incrementally, and as you're achieving success in the early phases.
That's great. Paul, you had your hand up, I saw.
Yeah, and I kind of want to reiterate on what David is saying. And so, you know, you don't have to have everything figured out yet for phase 2, level 3 yet, right? So you're got to focus on, like, what are they asking for right now for this part of the competition, and what do I need to submit my proposal to this phase? And so, you know, phase 1 could be just one person if you have the time to do it, but you might not know everything about this other topic that is part of this thing. And so maybe you need to find somebody or, recruit somebody that knows about that particular aspect. And so, at my university, so, I have my students do most of the recruiting, but the first we have to make is a plan and say, well, okay, this is what we need to achieve. And we need these kinds of skills because this is what we need to achieve the project. And then we go recruit for people that can do those kinds of things. Right? Somebody was asking, do you train that person? The problem is that I don't necessarily have that skill. So even if I would hire somebody, I can't train that person because I don't have that skill necessarily. So it's important to recruit people that already have that skill, because also the timeline's fairly short, and so it takes time to train. And Nadun was saying that he learned a lot along the way, and you can do that if you have enough time. But there's a limit to how much you can do and how much one person can do. So it's really important when I was talking about the strong leadership is to kind of understand what your shortcomings are and what your capabilities are. Like what can you realistically achieve and know when you need help and thus need to recruit more people. I think that's really important realization. Now, on the other side, don't just make a team to say, oh yeah, we have a great idea. We have 20 people, all friends. Let's just participate, because a lot of people might be bored or have the wrong skills. And I don't know about other people, but I've tried sometimes working with friends, but after working with friends, they're not friends anymore because the work ethics doesn't quite work together, right? And so it's kind of tricky to make a really good working team. And the key here is performance. You got to make sure that you get people that can do what you need.
Mm-hmm. Thank you. That's good. I've got a couple of questions about this as well. We talked about structuring your teams, but do you felt like you did a lot of informal collaboration, or did you, once you formed a team, what legal hoops did you feel like you had to jump through? We've got questions about LLCs and things like that. Did you have to form an LLC? And how did y'all navigate intellectual property considerations within the team?
Yeah, I would love to take a first stab at this.
Okay.
Yeah, there's no great answer, but I think the most important thing is what you just mentioned, True, which is IP. Okay, so I think, space fact, we already incorporated before the challenge, but if you were, say, a team of people and you're just want to do this, I would say incorporating makes it very complicated because you don't yet know how individual members are going to contribute down the line. And so determining ownerships of a company right off the bat is very difficult. Okay. And it will make it a headache later when you try to sort out and try to boot members, say, from an LLC. You don't want to get into like legal, you don't want to spend money on lawyers at this, I'll put it that way. But the benefit of having a company is that the company retains IP. So you can bundle up your IP and that makes your idea investable. Okay. Because at the end of the day, what an investor is going to be trying to buy into is your IP, okay, and your team. What I would recommend, and again, this is just my opinion, is if you're just a team starting out and you're not incorporated already, just develop an IP framework. Okay. Basically, everyone on the team states that, and everything I do for this competition, the IP will be owned by this future entity. Okay, if we decide to incorporate at some point. I think you start thinking about incorporating if you're in phase 2 and have made sufficient progress towards that goal. Phase 1, just have like a well-structured agreement amongst the team members.
Okay, thank you. Would anyone else like to?
I'm gonna jump in here too. So because there might have been some confusion in the chat, just so everybody watching knows, NASA does not retain any of your IP. If you participate in this challenge, you retain all of your IP. We can't take any of your ideas. We can't take any of your IP from you. So you retain it. You have to figure out though how you distribute that amongst your team or your organization. So please don't feel nervous that you might submit something, not win the challenge, and you quote unquote lose your IP. You did not. NASA will never retain your IP.
Thank you.
I think
That's
that's
very helpful.
Yeah, that to what Christopher said, and also David. For us, yeah, because IP it's a very slippery slope kind of thing for us. That's what I thought from Australia from point of view. So we'll luckily be planning on doing our initial registration with WIPO. So the thing is, it's 36 months. So if you don't think, you might lose it because of public disclosure, register it because you got 36 months to do individual countries. That's a benefit. And then if you have that peace of mind, it's good because the registration date is always what matters in the future. And then the second thing is, if you are developing IPs with universities, because this is a secondary kind of thing that we learned. Private organizations have reluctancy when it comes to university joint IPs. So it depends on the segment, sector, who your commercial customers are. So for us, luckily all our primary IPs are owned by our company, our holding company. So we kind of make things easier. So if you have secondary IPs, then it's great to work with universities because universities' main engagement with private organizations or startup on like any challenge or program with space or otherwise is for them to have an IP ownership. So that's a critical component of a university relationship. I mean, that's from what we see in Australia, and I'm assuming it's quite common in around the world as well. So if you are going on that platform, trying to have those discussions early, because these are the things you don't want to delay till 3 years down the track. So yeah, do your DD in regards to who owns the rights, who's the inventors, and all of these things. And understand your timeline is limited to 36 months from the day you register it. Thanks.
Yeah, for me, and I think IP is so important. I didn't understand what IP was when I started the company, honestly. But it was a very vague concept. But I think for a tech company, IP is critical, and it's the value, it's the actual, say, monetizable value of your idea. Okay, so as you move through this, true, NASA won't take your IP, but your results will be public. So you want to move to protect them. So if you're really confident you have a good idea, file a provisional patent around it. In the United States, it's 1 year between public disclosure and when you can file patent, but you might invest, in a provisional patent, sort of low. It's relatively low cost and easier thing to file. It's probably a longer discussion than we have time for in this webinar, but it might be one for a future webinar. This whole idea about, IP management, protecting your ideas, entering into agreements with your teammates, things like that.
Thank you.
Thank you. So thank you all. I'm gonna take it back for a couple final thoughts for everybody, but really appreciate all of you panelists. Just for all you people watching this, we have panelists on here that it was 4 a.m. when they started back at home. So they wanted to join us so that they could share with you their experiences and make sure you understand the lessons learned and the opportunities and the pros and cons of participating. But hopefully everybody feels inspired and feels it's doable. As one of the panelists said, we really try to keep phase 1 to be a very low barrier of entry. You don't actually have to build something, at least in the prototype track. And then the digital twin track, it's at a lower fidelity. So hopefully it is just sweat equity at this point. And then as you get traction, you are able to get investors, or you're able to get a little bit of prize purse or whatever to move on. So thank you to all the panelists. Really, really appreciate you. If you go next slide. So here's a couple call to actions, right? So we posted in the chat, the LinkedIn community group. I'm sure a lot of you went there to join. You do have to be approved. The people that approve it are on this webinar. So that's why you did not get an immediate gratification of being approved. So please go there if you're looking for team members or if you're looking to join a team. This is a very hands-off way to do this. We are not going to matchmake. We cannot matchmake. So you're going to go there and just start discussions with other people there, and hopefully hopefully it'll work out for you, and that you'll either find a couple people for your team or you'll find a team to join. Please stay in the loop by signing up for emails at the LunaRecycle website that's here. There's places, expression of interest and learn more. Just give your emails there. There has been some confusion. It sounds like some people have been emailing submissions to these email addresses. As True said, please don't do that. The only way we can accept your submissions is during the registration process, which will be opening very soon, and all of you will be made aware of that. Please share information about this. We'd love to get more people interested. And then, of course, if you have any questions, go to our website. There's FAQs. They're actually organized by eligibility, technical, blah, blah, blah. You should be able to find there. If there's something that's not there, please send us an email at lunarecycle@ua.edu, and we will formally put it on the website if it's a relevant question. Same thing with the Q&As that we did not answer here. If it is about eligibility or rules or something, we will address those and add them to the website. So that is all we have. We want to say thank you for participating today. Thank you for sticking with us for an hour and a half. We hope you got your questions answered. We hope you're inspired. We hope you submit really cool ideas. So thank you, everybody. Have a great rest of your day.
Thank you.